I am SUBHASISH Patra. Welcome to my next video on ETAP software of modeling a tall building. In this, today we will open the same module which we have done earlier, but in this module we will use seismic load. The seismic load are the loads which are subjected to a building when an earthquake occurs. Means these are the load occur on a structure on the time of earthquake, and today we are going to analyze that how a seismic load is going to affect on a building. We will analyze it by two process. One is response spectrum process and another is time history process. So first of all, we will open our building design which we have made earlier. Like this is the building model which we have made earlier, and we can see that the building is locked as analysis and the design has been run on this. First we will unlock this and press OK, and it's all done. And now we will go to define menu, and here we will define firstly the loads, and the loads we are going to first define is the seismic load as we have defined the wind load. First we will go to the define menu and go to the load patterns. In the load patterns we are going to delete this wind load because we doesn't need the wind load now, so we will delete it. Yes, and now we will type a new load, that is seismic load, and here we will use the IS code 1893-2002 and press OK. Go to define load patterns, go here to seismic load, IS 893, here coming with the IS 893-2002. I am going to go to add new load, and here the load is added. Now we will modify this lateral load at is it a lateral load, and first of all we will change this to X and Y direction because we are calculating for both the direction. Now as we know the building is on Bangalore, so we will first calculate this seismic coefficient. First is seismic zone factor. So how can you go to the seismic zone factor? We'll go to the IS code 1893 and we will use this map which is given here, and the Bangalore is somewhat here, so it is in zone 2, and for this we will go to a chart, the zone chart here, and the seismic 2, the zone chart is 0.1, so we will just type here 0.1. Now this is a site type, so for site type we are again going to consult our IS code here, and we are going to find the site type. Here in this figure you can see this is the site type, and for type 1 it is rock and hard soil, for type 2 it's medium soil, and type 3 it's soft soil. So we are using for Bangalore a medium soil, that is type 2. So this is site is type 2. Now the importance factor. Now again going through this IS code we can find the importance factor is given here, the importance factor I, and it is for hospitals, schools and monumental buildings, and residential building is 1.5, and for other building it's 1. So taking it as a residential building, the importance factor should be 0.1, 0.5, and as the time period it will be should be program calculated. Now response reduction factor, here response reduction factor we will again go to our ICE code and find here the response here on the table, that is response reduction factor, and we can see our response reduction factor, the building system we are using here is ordinary reinforced moment resisting frame, and for this the R is 3, so we will put here changing it to 3 and pressing here OK, and it's done, and we will here press OK. So our load is defined, our seismic load is defined here, and now we will go for load combinations. We will go for the load combinations, and here we can see the formulas for the load combination, that is 1.5 of seismic, the seismic load are given, all is given. If not, then add default concrete frame design and press OK. So all the load designs are here given. Here you can see the load type, seismic load type and wind load type, and all the type of load combination is given here, and just press OK. Now for seismic design, none of the structure is to be selected because it will be act on the overall structure. So we will direct go to analyze and set load case to run. Why set load case to run? So that we can see which things are running here. Now on the set load case we will see which load is running. So dead load, live load, model load and seismic load. So it's okay, and now we will analyze our with run now option. And it will take some time for analyzing the frames structures. And now the analysis has been done, and we can see the deflected shape of each and every structural members here in the 3D tab, as it is default tab for showing this. And if we will press we will take the cursor in any of the member, any place, and we will get the displacement of this place. For more stresses option, we can go to here display option, force and stress diagram, and frame piers spindle or cell stresses forces. From there we can get. Now we will design the structure. First we will go here concrete frame, we view revise and preferences. Here it is IS 456-2000, so it's okay. And now again we'll go for design concrete and frame structure and start design check. It will take some time. And we can see here that the design section defers 10 concrete frames. It means that we have select the auto select option and it is given that 10 concrete frames are not. So we will reiterate it once again and we'll press yes. The design check is going on. And here we say that 8 concrete frames, we will again put yes. Again we can see that 7 concrete frames, we will again reiterate it. Again we can see that the 7 concrete frames, we will put yes. You can see here that all the reinforcement details are provided and there is no option coming, no warning option coming. So from here we can take details of any of the beam, just clicking on that beam or column, right clicking on this beam and column and just getting the details like this. We can see here the required flexural moment bars and also the shear reinforcement here of the given beam. Now just for checking that whether the all member have passed or not, we will just go to design, go to concrete frame and verify all member passed, and we can see here the dialog box says all frame concrete has passed. We will press OK, and this is our design for the seismic load. And now for any other display we can display here, and we have the reports here, the project report, the summary report. We can get the summary report by clicking here, double tapping here. It will take some time. Here the report will be ready and you can analyze this report for further your work. And in this type we can use the seismic load to define in a tall building. Now this seismic load has been done, and now we will unlock this figure again, so that all the analysis result will be deleted. We will press OK, and that's okay, that doesn't even matter. And now we will use response spectrum method for the analysis. For the response spectrum method, first we have to define it. So for response spectrum method, we will go to first define, and then we will go to load patterns for checking the seismic load and also check it is modified or not. Yes, it is modified, and that's okay. And now OK. We will press OK for both the time, and now we will define the load. We will go to define, we will go to function, and here is response spectrum. Here will be changed to 1893 2002, and we will be add new function. Before this we will modify and show spectrum. Here it is all okay. We will press here OK and just add new function. Just adding new function, we will write here the name response spectrum. The function damping ratio you will get on IS code 1893-2002 on 7.8.2.1, and it should be 0.05, so it is okay. Now we know the zone factor here. The zone factor is 0.1, so it's 0.1, okay. And soil type is 2, and that's okay. And linear x and y direction, and that is also okay. So we'll press OK here, and we will get the definition here, the response spectrum function. We will press OK and just come out of it. Now before going for another, first we have to check the unit, and we will go to option here, display unit. Here we will check the unit of acceleration because it is going to be used next. Here the acceleration is mm per second square. We will press OK, and that's now we will go to define option again, and we will come here to the load cases. In load cases we can find dead load, seismic load, and now we will add a new case. Add a new case, and the case name is response spectrum. That is, we have firstly defined as response spectrum here, and now we will add acceleration u1 and default function type. Here it should be rs, which we firstly defined. Now we are going to scale factor. What is scale factor? Scale factor has a formula that known as I into G divided by 2R, where I is the importance factor, G is the gravity acceleration, and R is the response reduction factor. As we perform this thing, we will get a value that is 1633.5, because here I is the importance factor is 1.5, the gravity acceleration is taken as 981 mm per second square, and the response reduction factor, as we have earlier discussed, it was 3. So we will get a value 16.335, and we will add this, and again we have to acceleration in another direction, that is u2, and response function will be rs, and the scale factor will be same. The scale factor doesn't change, and like this it is done. For all the peak response quantity, we will go to CQ-C3 here, and damping ratio will be like, check for the damping ratio, that is 0.05, that's okay, and here we will press OK. Now this is done, and we'll press OK here. So definition of our load is done. Now we will analyze the load. For analyzing, we will go to analyze, set load cases to run, and here we doesn't need dead cases, so run do not run option, which action is coming to do not run, and here also do not run. Now the both are cases, seismic and RS is running, and we will go to run now option here again. For running the analysis. It will take some time to analyze the model. And here in the 3D tab we can watch all the spectrum for this, and just we have to rotate it to get a view of the building response, how it has responded to the response spectrum and the seismic load. Here it is done here. We can also start the animation at any time. For other information we can go to display, we can go to display here. We can take story response plots, and we can watch the response plot here like this. All stories blue and red. The displacement, the maximum displacement at the and the minimum displacement is at the base. We can work like that, and just clicking cut. Now we'll design it. It's very easy. It is read earlier. Just go to design. First check the view and preferences. Check the IS code here. That's okay. We will click OK here, and then again design, complete frame, and start the design check. It will take some time to run the design check. Here you can watch that there is 9 complete frames differ. We will reiterate it. Yes. And wait for our result. Here we can watch that our analysis and design have been done, and there is no option coming. So we will just check going design. We will go to complete frame design, and we will verify all member passed, and yes, option is verify member passed. We press OK, and here you can watch that the longitudinal reinforcement of the any beam, any column, and all the things. For this we can get the report here, going report here, and we will get the summary of the report as well. And we can get all the reports here, all the reports as given here, and we can analyze this report. So like this we can use the response spectrum for any building and calculate all the analysis about it. And now after this we will use the time spectrum method. For this again we have to unlock the model. Yeah, pressing OK. And all the analysis we have done will be get deleted here. And now for this we'll first define it. We will go to define menu, and first check the load pattern option where we will get the seismic and this okay, and will be come out of this. And now go to define and load cases. The load cases, we doesn't want the response spectrum anymore, so we will delete this case from here and we will add a new case. With the add a new case, we will write time spectrum. Time history method. You will get the time history when it's done, and here will be add. To acceleration u1 and skill factor will be same because the skill factor doesn't change if it is time history method or it is response method. Yet output split, it's all is done, and we'll press OK here. Here we press it OK. I'm going to define the function. Here function, the time history. Here we will go add new function, but before that we have to go from file. Okay, we will tell it later why. Here we will write here time history. I will browse the file. This is the time history data which we can get from any places, for time history of any place. For this we are getting the time history data, here the time history data of Bangalore. Here before this we have to put the header line to skip, the prefix, character and line stop, and the number per lines. For this we have to view file first. Now here we can watch the first, the header line is 1, 2, 3, 4, 5, 6, 7, 8 and 9. Before the data start there are 9 lines for the skip. So we will cut this and put the header line as 9. Number point per line should be here given 1, and it should be fixed format. Character per should be 10, and this is done, means the function has been defined. We will press OK. And we can see the example history data here done. It's all done. We can modify the name as well for our convenience. Here we will write time history and OK. Here, and we will press OK. It's done. Now going define again to load cases. Time history modify show cases, and here we will take the time history. Here default should be time history. It's done. It's all done here, and we'll press OK here and OK. Now we will go to define. We will go to load combination, and we will take account all the load combinations here. So here we will add default design combos for concrete beam design, and we will add all the cases here. all the load cases needed are added here. You can watch the formula for all the load cases here. Now we'll press OK and leave this. Now time history data has been putted here and all the things are done. All the things are provided, all the data is provided, and now it's time for our analyze. We'll go to analyze option, set load cases to run, and again we don't want this dead load and live load to run, so do not run. And now seismic and th only, that is time history, and we will run now the option. Here we can watch in the 3D view tab all the things and all the displacement due to time history data and the seismic load. For this, for display of another things, we can come here, we can get the story response plot, we can get combined response plot. Going combined response plot first. We are getting all the combined response plot, the displacement, the maximum displacement in both the direction, and here we will get all the drift, and by clicking we can get the maximum drift at the points. Here it is the shear, and here it is the overturning thing. The load case is th, we can animate it as well. We can animate all these things for our convenience. Just getting out of it. Just click cut and we can come here. Now all the things are checked. You can check another as well. We can go to display menu and the force and stress diagram from there can be checked. Now we are going for design as usual. Go to concrete frame, view revise preferences first. Yes, it is on IS. We will press OK. It's done. And here design, concrete frame, and just start our design. And we can watch here, the results are given here, all the results, all the reinforcement are given. We will just check the data if all the member has passed or not, verify all the member passed, and yes, we can getting that the concrete member passed the design check. So pressing OK, and this is the design, and this is the last design for this. We have done the time history, we have done the response, we have done the spectrum. We can get here the summary of this report, of this time history. Yes, we have get the report here, and we can analyze it report for the further cases. We can also get the project or detailed report here that will give all the things. get the report. It is taking some time. And now we can see here the detailed project report of this time history process and all the things we have got. With this thing, we will end this project, and thank you very much.